organic. Yeah, but you have to have 101.
Yeah.
3, I hope.
Yeah, I'm taking 101,
I've already taken my chem lab.
4.3.
I'm taking my chemistry class in lab this fall. That's right.
Okay. It is lecture 13A, isn't it? All right, I think we're at lecture 13A. I forgot my pad.
Is your mic on?
Nope, but you know what? My pad's in the back. That's why I couldn't find it.
Just
The
not.
camera rolling? Yes. It is? And so everybody knows that I couldn't find my pad?
Oh dear.
Huh.
We are at 13A. All right. And my mic is on. Good. All right. Welcome, everybody. We are at lecture 13A, finally. We're going to review for test 2 today and then hopefully begin the material beginning of test 3, 4.4 logarithmic functions. But since we're reviewing for the test, I got a long list of questions from the group that's here. And the group said, let's start at 3.2 with questions and work forward. So we will do that. And if you had a question about a problem we go over, or maybe I don't say something about a particular part, be sure you chime in and ask some questions about that. All right, so we are in section 3.2, and the questions are coming from the exercises in 3.2. 3.2. So 3.2, and we're going to start out with problem number 3.2. First question looks like it maybe comes from number 45. Let's see what that is. 3.2, number 45. We're supposed to list the zeros and the multiplicity, determine where the graph crosses or touches the x-axis, and find the power function that this graph resembles for large values of the absolute value of x. In other words, it's asking that if you look for miles away at the graph of this function, would the ends of the graphs be going in opposite directions or same direction? What basic power function is it looking like? Okay, so we are looking at problem number 45. I think a lot of this we can just answer right from the question. This problem is already completely factored for us. So is it very easy for us to tell what the zeros of the function are?
7 and negative 3.
7 and negative 3. Those are the values that make the y value 0.
Right.
Okay? Multiplicity. That just means how many factors do you see, which means if the 0 is a multiplicity 1, 2, or 3. You probably knew how to answer these questions. Okay, so 7 is of multiplicity 1, and negative 3 is of multiplicity 2. All right, how do you determine whether the graph ahead of time, before you sketch it, is going to pass through the x-axis or going to touch it? How do you determine that, everybody?
Odd or even.
Okay, is the degree of the polynomial function even or odd? Okay, if it's, not the degree, excuse me, if the factor is even or odd. If the factor is even, what's going to happen? It touches and turns around. This is written out for you with some examples. Back on page 325, page 325. If R is a 0 of even multiplicity, and if R is a 0 of odd multiplicity, if it's odd multiplicity, it crosses. If it's even, it touches. All right, so in our example, number 45, 7 is of multiplicity 1, so is it going to cross or touch? Cross. And negative 3 is of multiplicity 2, so it's going to touch and go back around. All right, now, what is the degree of this polynomial function? Okay, if you multiplied it out from this factor, you would get an x squared. The first factor is just an x, so by the time you multiplied x times x squared, the leading term is going to be an x cubed term. So that just means when you look at this from a long ways off, it's going to resemble what power function? Ax cubed. Y equals ax cubed. Okay, a power function, as you'll remember, back here, somewhere at the very front. Power function on page 319. Power function is just one term, and it's ax to the n. So this particular power function will look like a x cubed, and actually it would be a 3x cubed, wouldn't it? Because you got a 3 out front, so the a part is 3. So it's going to look like 3x cubed from a long ways off.
That's how you write your power function.
Yes, 3x cubed. Do you know where the x cubed came from?
I know the x cubed came from.
Okay, everybody good on that?
So that is the power function?
Yes, 3x cubed. So for the other question here that was number 55, is that the same question about the power function? You got all the zeros and all that stuff, so the power function. Okay, let's concentrate on that then. All right, if you were going to multiply out number 55, you would get minus 2x to the 4th as your leading term, right? So, I mean, you'll have another term, but the term of highest power is at x to the 4th. So what would be your power function?
Negative 4. Negative 2.
Negative 2x to the 4th. Okay? All right. Questions? By the way, what are your zeros in number 55?
2.
2
2. 0.
and 0. A lot of people forget that 0. You got to set each factor equal to 0. So,
Would it still be 2 with the x squared right there?
oh,
It'd be
that's
half.
not right.
It'd be a
Plus or
half,
minus.
right? It'd be a
Right.
half.
No, not half. What is it?
Plus or minus 2.
Plus or minus what?
The square root of 2.
No.
Plus or minus.
X squared minus 2 equals 0. X squared equals positive 2. X is equal to
Plus minus square root of 2.
plus or minus square root of 2. Remember your square root principle? A squared equals m. A is equal to plus minus square root of m. Square root principle.
All these other multiplicities.
The
1.
okay, the 0 the 0 0. 0 is of multiplicity 2. Square root of 2 is multiplicity 1, and negative square root of 2 is multiplicity 1. Okay? Everybody good? All right, just tell me, are the ends of the graph of this function going to be going down or up?
Down.
Oh, down.
Down, because there's a negative 2 in front of the x squared. All right, is everybody good so far? Number 76. Number 76. Bottom of the page, 331, number 76. Okay, the degree of this polynomial, what is it?
2.
76? If you multiplied all the x's out, what would you have?
X to the 4.
Right, the first one, if you multiplied it out, that's an x squared. And then that would be multiplied times the x and times the x, so x to the 4th. So what is the end behavior of this graph?
Both going.
Both.
They're going to be both going up because everything is positive. So on the outsides, the entire graph is going up. What is the power function that this is going to resemble? Power function.
The parabola.
Negative x to the 5th.
It will somewhat look like well, the ends will be going up, but it's a 4th degree, so what is the general power function?
X to the 4.
Yeah.
X to the 4th, and the coefficient in front of that is 1, because all the coefficients, if you multiplied all this out, would be a 1x to the 4th. Okay? All right. What are the x-intercepts? I'm looking at part B. What are the x-intercepts?
2, negative 2.
2, negative 2, and negative 4. That's where your y value is equal to 0. What's the y-intercept?
0. No, I'm sorry.
What's the y-intercept? How are you finding it?
10.
That is 0.
Let what be 0?
The f of x.
X is 0.
It's 10.
All right, so if you let x be 0, you have 4 times
2.
2 is 8. 8 times 4 is 32. If you're looking for the y-intercept, all you do is let x be 0. So you'd have 4 times 2 is 8. 8 times 4 is 32. So the y-intercept is 32. All right, we are going to graph this using really a sign chart. And we're not using graphing utilities to find the max and mins. You'll be doing that with your derivatives in calculus. Okay, so I have plotted the zeros. Here's the x-axis and the y-axis. Okay, so number 76, the problem is f of x equals x minus 2 squared, x plus 2, x plus 4. All right, we already know around x at 2, it's going to bounce back around because you got a square on that factor. You know at negative 2 and negative 4, it's going to cross through it, okay? But we're going to just sort of set up a little sign chart here, and we'll know really fast how to graph the thing. Remember, you pick around your intervals of 0. So we'll pick bigger than 2. We already know between negative 2 and 2 is going to be positive because it's got to hit that 32 up there. Then we'll pick between negative 2 and negative 4, and then less than negative 4. All right, but we really already know that it's going to go like this because it's positive, so I know the ends are going up. I mean, I already know that, but we're going to pretend for a second we don't. Let's pick a number bigger than 2, such as 10. If you put a 10 in for x, all these values of these factors is positive. So we know the graph is going up. Everybody got that? All right, we've already picked a value between negative 2 and 2, so we'll just swing this around like this. And by the way, we don't know that this is a max. We don't know that. So any way that you do this, as long as it hits 32 in here, we're good for, we're doing what is called rough sketch. Okay, we don't know that that's a max. Okay, relative max. Okay, between negative 2 and negative 4, easy number would be like negative 3, but we kind of have an idea already that it's going to come down because of analyzing the equation. So we expect really it to come like this. Okay, but we're going to pretend we don't. So put in a negative 3. This is always positive. Negative 3 plus 2 is negative. Negative 3 plus 4 is positive. A negative times a positive is a negative. Come down. Pick a number less than negative 4, such as negative 1,000,000. All right, that square term is always positive. Put a negative 1,000,000 in for x, you would have a negative times a negative, which is a positive. So you can do your little sign chart, you can do your analysis, you can do both as a double check. Is that good?
I got one.
Okay.
Why wouldn't you say from negative 2 to 0 and 0 to 2?
The question was, why didn't I say from negative 2 to 0, 0 to 2? Well, at x equal to 0, that is not a place where the function equals 0. So the graph has got to be totally above the x-axis or below because it's not passing through the x-axis between there.
Okay.
Okay, but I mean, if you did check, you would have found that it was positive on both sides. I mean, nobody says you can't do it, but there's not a reason because these 3 places are the only places the function is 0. Other than that, it's got to be above or below. Is that good? All right, are we experts on 3.2, everybody? Anybody questions? We're headed to 3.3.
All right, how would you, all right, I got a question. How would you find, would you ever have to find your range and your domain out of those?
His question was, back on this problem, do you ever have to find the range on this? If this one, we really don't know what the range is because we don't know how far it dips down here. If you were using a graphing utility, you could probably figure that out, and you will have to in calculus, but not in here. Now, the domain for this is very easy because you're just looking for, are there any restrictions on x, and a polynomial function is always a nice smooth curve to find for all x. So you wouldn't be asked for a range if you were graphing this.
Okay. What about the limit?
The limit, you could be asked for the limit. What is the limit as x approaches infinity of this function? As x gets really big, where does the y value head? in the direction of infinity. What about the limit as x approaches negative infinity of my function? As x gets really, really small, where's this graph going? Infinity. Okay? Is that good? These are great questions. I appreciate them. Everybody good?
Would that one be, it wouldn't be negative infinity on that side?
This says as x heads this way, x is going to negative infinity. This says basically what's happening to your y values.
Okay.
And as x heads this way, the y values are just getting bigger and bigger and bigger. Is that good?
Okay.
Yeah, but you wouldn't be asking y approaching.
And you wouldn't ask for vertical and horizontal asymptotes on the system.
Well, a polynomial does not have vertical asymptotes because it's not a fraction where you'd have undefined. And a polynomial does not have horizontal asymptotes because they're headed to infinity, you know, positive, negative, or they're both going up. They aren't approaching a y value. You're only going to get your vertical and horizontal asymptotes with a rational function or exponential or log or tangent. Okay, but not polynomials. Okay, everybody good? And there's a few other functions, but you know what I mean. All right, so we're on 3.3. Hey, that was fast, 3.3. And on 3.3, we're on page something like 344. And the first question on 344 comes from number 23. Okay, I'm in section 3.3. And we're looking at problem number 23. Okay, this is the graph of a rational function, and the little red dotted lines tell you you've got some asymptotes there. All right, for domain, you're looking to see, are there any y values not here? Excuse me, domain, any x values not included. So what is my domain for this function, everybody?
All real numbers except for 2.
All real numbers except x equal to 2, because you got a vertical asymptote there. The range is what y values are being left out. 1. Okay, so your range is all reals except for 1.
Y equals 1.
Right. Well, basically, if it asks for range, you'd say y not equal to 1.
Okay.
Can't be equal to 1. Everybody good on that? I don't remember who asked. Okay, vertical asymptote. Vertical asymptote. What is it?
Y 2. X equals 2.
Okay, if I get 2 on a test for this, why am I taking off points?
It's not x equals.
It's a line, and the equation for the line is x equal to 2. Okay, an asymptote is a line, not just a number, so you have to say x equal to 2. Does this have any intercepts?
Yeah.
Yeah, there's only one at 0, 0. Okay, oblique asymptotes is not an objective, but there are none. Oblique is when you have a vertical, not vertical. This is oblique. Diagonal line, right. Does this have a horizontal asymptote?
Yeah.
What is it?
Y equals
1.
1.
Y equals to 1. Again, if you just put a 1, you lose points because it is a line, y equal to 1. Is that good on 23, whoever asked? Okay, 23 is good. There was a question about number 28. Number 28. All right, what's my domain here?
All real numbers except that x can equal -1 and 1.
X can't be 1 and -1. It's all other real numbers. What is my range?
0. Maybe R is 0.
All real numbers?
All real numbers except for
0.
0. Because your y value...
Oh, yeah, you
Oh, wait, that's not
it-
true. Goes through there, so it's all real numbers.
All real numbers.
Because the curve between -1 and 1 actually goes through 0. This is one of those examples where it crosses through a horizontal asymptote. Okay, what are the vertical asymptotes?
-1 and 1.
X equals -1. Everybody needs to say that. Say that.
X equals -1 and 1.
And x equals 1, right. Okay, what is my horizontal asymptote?
Y equals 0.
Y equals 0. And you only have one intercept here at 0, 0. Is everybody good with these graphs?
Okay. All right, can I ask one question?
Yes.
What, 25?
25? 25 has an oblique asymptote in it, and that was not an objective of the course. Hopefully that wasn't stuck in WebAssign.
There was some complete
There-
hours.
There what?
There was, but all the answers were no.
Okay, if they're there this time, that's because at this particular moment, those are new WebAssign questions for this book, and hopefully by those people watching it by video, we got all the mistakes out.
On the last one we just did,
Mm-hmm.
why is 0 a horizontal asymptote when there's a line that goes through it?
A curve can cross through a horizontal asymptote. The definition of a horizontal asymptote is as x gets really, really small or x gets really, really big, does the y value start to approach a number. But a curve cannot cross through a vertical. It can touch a vertical by a piecewise defined function. But a horizontal, it can actually cross over a horizontal.
Okay.
Got it? All right, everybody good? All right, the next question was number 37. 37. Okay, graph the rational function by transformations. Okay, 37. Let's graph that real fast. This is page 345. Oops, I'm off the sheet. 345, number 37, and it's g of x equals 1 plus 2 over x minus 3 squared. Okay, what's my basic function here?
1 over x.
Yep, y equals 1 over x squared, because you got a square there. Okay, I'll try to do each part with a different color. All right, what's the next step? Transformations. Vertical, stretch,
By factor 2.
by factor 2. So we're going to do y equals 2 over x squared. Okay. Oops. All right. What is the next thing? You want to do the one next?
Yeah.
What's that going to be?
Shift up.
Vertical, shift, up, 1.
The
Okay.
2 on the top, that means vertical stretch.
Vertical stretch.
You multiply.
Multiply the y values times 2.
Doesn't look like you multiply.
2 over x
Oh,
squared is the
it's
same
1 over-
thing as
Ah,
2 times 1 over x squared. That is a common mistake. I'm very thankful that you mentioned that. Okay. Alrighty. And then
Horizontal shift.
you're going to do a horizontal shift. Which way?
Right. 3.
Right 3. Everybody got it? Okay, so here we go. In blue, what does y equals 1 over x squared look like? Okay, goes through 1, 1. Your y is always positive. Negative 1, 1. What's your asymptotes?
y equals 0 and x equals 0.
Yep. I'll write it right here. Y equals 0, x equals 0. Asymptotes.
Now, on the, why x? Like, 1 over x is the opposite way.
Yeah, 1 over x would have been here and down here.
Okay.
Right. Okay, now we're going to do a vertical stretch of 2. Stretch by factor of 2, so the y values are multiplied by 2. So now 1 times 2 is 2, so now we have the point 1, 2. And negative 1, oh, that's a positive 1 right there, sorry. Negative 1, positive 2. Still going to look kind of the same, except that it's going to come like this. Okay. All right, you're just doing those x values are being multiplied. The y values are being multiplied by 2. Okay. All right, vertical shift up 1. So if we do a vertical shift up by 1, that means, whoops, that's the wrong color. That means all the y values are going to have 1 added to them. So what does that do to my asymptote?
Move it up 1.
All right, y equal to 1 is an asymptote. And we're still at x equal to, I'm lost. I just lost myself. X equals 0 is the y-axis, right. Okay, so vertical shift up 1, we're going to add 1 to the 2 on both sides. So now we have 1, 3. And negative 1, 3. And we've just shifted it up where it's going to approach this asymptote. Okay, you could plot some other points, but we're just trying to get a good idea. So this is the point now, 1, 3, and negative 1, 3. Everybody good so far? Y'all are good at this, usually. All right, horizontal shift to the right of 3. What's that going to do? You got-
vertical asymptote over the view.
Yeah, you're going to add 3 to everything related to x. So you're going to add 3 to the 1 and 3 to the negative 1, and x equal to 0, which is your y-axis, you're going to add 3 to it. So now for the green, y equal to 1 is an asymptote, x equal to 3 is an asymptote. Just draw it like this. So now we have 1 plus 3 is 4, 4, 3, 4, 3. And you add 3 to the negative 1, and now you get 2, 3, 2, 3. And your graph looks like, whoops, I made that dot a little too far over. Looks like this, and it looks like this. Okay, and let's just do a little double check here. If you let x be 4, 4 minus 3 is 1. 2 over 1 is 1. 2 plus 1 is 3. If you let x be negative 2, negative 1 squared is 1. 2 plus 1 is 3. And you know right away by looking at this, you have a vertical asymptote at x equal to 3. And you could find your horizontal asymptote easily if you got a common denominator and got it to a single fraction. Okay, but there you go. How's that, whoever asked? Sarah, did you ask that one? No, you asked that one. Are you good?
What about when I'm like refused to do numbers one like number 35? Would you give us one I get on the test?
Well, number 35 is just asking you, you would just factor it. Here's your question. This question was about number 35. You would just need to factor the denominator to, what, x plus 2 quantity squared. So the graph would look like negative 1 over x squared, and then you just do your shift. Yes?
I have a question. On number 37, the vertical asymptote, was it first x equals to 0, and then it became x equals to 3?
Yes. If your basic function was y equals 1 over x squared, your vertical asymptote was x equal to 0. But when we put in the shifts by the end, your vertical asymptote is at x equal to 3.
Is that only with the horizontal shift, or?
Yeah, that came with your horizontal shift because of right down here. But if you look at the function number 37 before you did anything to it, you would automatically know x could never be equal to 3. So your vertical asymptote is x equal to 3.
Okay.
Is that good?
Yeah.
All right. 3.3, 47. Let's see what that looks like. 47. Okay, number 47, all we're asking for are vertical and horizontal asymptotes, and we're not worried about obliques. Okay, and first of all, you want to make sure your function is reduced to lowest terms. Reduced to lowest terms. Remember that if you had a common factor, if you simplified, you might have that line with a hole in it. Remember the example we did? Okay. All right, so this one's reduced because the degree of the numerator is less than the degree of the denominator. All right, what is my vertical asymptote? All you have to do is just look at it. What is it? Vertical.
X equals 3.
What makes that denominator equal to 0?
0.
0. 3x to the fourth would be said equal to 0. X is 0. So the vertical is x equal to 0.
I thought you look at the degrees.
That's horizontal.
What do you do for vertical?
Vertical, you look in if your rational
You
function
find
is
0.
reduced to lowest terms, you're looking at what your x values can never be. Vertical, x equal.
Vertical can also be the zeros of the denominator, right?
Oh, denominator.
Yeah.
That is what it is. Yes,
So what's the one where it says it could be the leading coefficient?
that's horizontal.
Okay.
Horizontal. Okay, for vertical, you just look in the denominator after your fraction is reduced to lowest term to get rid of all your common factors. Okay, for horizontal, the degree of the numerator is less than the degree of the denominator. So what does that mean you do to find your horizontal asymptote?
The leading coefficient of the numerator.
The degree of the
Right.
numerator
Okay, it's
is
so it's
less
the
than the
leading
degree of the
coefficient
denominator.
Denominator.
Excuse me?
The leading coefficient of the denominator. Is it, wait, what problem?
When
Okay, back on page 343.
it's just equal to 0.
If the degree of the numerator is less than the degree of the denominator,
Why?
and it's a proper rational function, meaning the degree,
Oh, yeah.
On top
You're
is
right.
less than 1 in the denominator?
right? Yeah, because it says then. The graph will have a horizontal asymptote, what?
Y equals
Y equal to 0. That's because your denominator is such a bigger number than your numerator as x gets really big or small.
So
So
when it's
if-
the other case, that's when you divide by the leading coefficient
Right.
of the numerator and the leading coefficient.
Right, we'll look at that. Okay, so for 47, your vertical asymptote is x equal to 0. That came from your denominator. Your horizontal asymptote from the rule is y equal to 0 because your degree in the numerator is less than the degree of the denominator. Let's look at number 50. Let me see if I can factor that real fast. 3x minus 2 plus 1. Is that right? Negative 6. Yep. And what does the numerator factor?
Nope.
Yeah, does not factor. Okay. All right. So this is already reduced. It's a proper rational function here. All right. So what's my vertical asymptotes, everybody?
-1 and 2.
Or am I going to take a negative 1?
Oh, -1 over 3.
Okay, but am I going to take you to just tell me a vertical asymptote is negative
X
1/3?
equals -1.
X equals negative 1/3, and what else?
X equals
X equals 2. Okay, vertical. Horizontal, the degree of the numerator is the same as the degree of the denominator. Little part in number 2 summary. The degree of the numerator is exactly equal to the degree of the denominator. Okay? So, what is the horizontal asymptote?
The horizontal asymptote is 2/3. Or 2.
6 over 3.
2.
2. Y'all just going to give me 2 on a test?
Y.
Y equals
Y.
0.
Y equal 2.
So you take the leading coefficients and then reduce.
Yep.
But only if the exponents are
Only when the exponents are exactly equal, then y equals the leading coefficients is the horizontal. Let's find another one real fast.
And the vertical asymptote of that is
X equals
-1.
minus 1/3. X equals 2.
Oh.
You got to set each factor equal to 0.
Oh, okay.
What about number 42? What's your vertical asymptote? Say it fast. Vertical asymptote.
X.
X equals 6.
6. Oh, wait.
What is your horizontal asymptote?
3.
Y equals
Y equals 3. Let's look at number 44. That factors to what? X minus 3,
Minus 2.
X minus 2. Okay. What's your vertical asymptotes? Number 44.
X plus 5.
3.
X equals 3 and X equals
X equals 3, X equals 2. What's your horizontal asymptote?
-1.
-1.
Not just
Y
negative
equals
1.
-1.
Y equals negative 1. Y equals negative 1. I just want to ask, what is the, number 45, what is the horizontal asymptote? That's all I care about at this moment. What's the horizontal asymptote in number 45?
Equals 0.
Y equals 0. Why?
Because the numerator is less than
The numerator degree is less than the denominator. All right, we're off section 3.3 or we'll never make it through. Everybody good? Let's go to 3.4. 3, oh, you didn't do 3.4. 3.5. 3.5. Okay, 3.5, we have questions. Number 5 for 3.5. When you're solving inequality, what's the cookbook rules?
one side equals 0.
You got to have a 0 there. So number 5.
And if you change the sign, or if you change your inequality, then one is going to be a negative something? Is that
If it's a linear inequality, if you multiply or divide through by a negative, you reverse the sign.
okay.
If you have a quadratic or higher power, you're going to have to go with a little sign chart to help you out. But you always got to have a 0 on one side. Okay, that already has the 0. What's the next step?
Add.
How do you know where you're going to check around on your sign chart, everybody? I'm on page 365. Did I forget to tell you that little tidbit of information? I'm on page 365 in section 3.5. I'm solving for all x that satisfy this inequality. I had to get a 0 on one side. What's the next step?
Factor.
The big F word. Okay? And now we're just going to a little sign chart because we would know what would make this equal to 0. That would be where x is 0 and x is 4. Am I going to put a solid dot or an open circle on the 0 and 4? Why am I putting open?
Because
It's
it's
not included.
Straightly greater than 0.
So open means
Don't include it, but get as close as you can.
always.
Solid means you are solid as a rock. You're there. Okay? All right, then we just pick around these values. So if I picked a 10, would this inequality be positive or negative if I put a positive in for x? A 10 in for x? Positive. What about if I put in a 1 for x?
negative.
Negative. If I put a number less than 0, such as negative 100?
It would be positive.
Positive. The question says, what values of x make it positive? The greater than 0 says, what values make it positive? Let's do that in interval notation. How do I represent this in interval notation?
X
For
is-
bracket.
Square bracket or open parenthesis?
Open parenthesis.
Open parenthesis, headed to infinity. Put a little union sign in there. And then less than 0, you would do what? Negative infinity up to 0.
Will you write it the other way? Like they have it on Webisoft?
X greater than 4 or x less than 0.
And what is that top notation called?
That's called interval notation. Interval
And the The other one that you did?
I don't know what that's called. I'm not sure. Just called
The other one.
what x is, I guess. You could probably do a set notation if you want to. Set of all x such that x is greater than 4 or x is less than 0.
Which one do you want on the test?
I want the correct answer on the test. If I don't ask for interval notation, you can do it any way you want to. Okay? All right, everybody good? All right, you had several questions on 3-5. You probably don't want to do all of them. 21, you're going to do the same deal where you look at what makes it 0 and then just do a sign chart. So you check around, 1, 2, and 3. So I think that was very similar. 27 we did in class already. 43, let's look at 43. I'll write it down. Number 43. You have x plus 4 over x minus 2 less than or equal to 1. Solving an inequality, what's rule number 1?
Gotta have a 0.
Gotta have a 0 on one side. So, let's subtract 1. Okay, before we can have a sign chart, you got to get everything to the big F word, which is factored. But I got two terms here. What have I got to do, everybody? Common denominator. So I have x minus 2 over x minus 2. So my common denominator there is x minus 2. So I get x plus 4 minus x plus 2 when I distribute my negative. All this over x minus 2 less than or equal to 0. The screen pen's not showing up very well, is it? Everybody okay so far?
What's that? X minus 2 over x minus 2?
When I was going to add x plus 4 over x minus 2 subtract 1, I had to get a common denominator before I could subtract. So I multiplied this by the factor x minus 2 over x minus 2. And then carefully distributed the negative. Is everybody good? So this gives me 6 over x minus 2 less than or equal to 0. All right, so what numbers am I going to check around? There's no way this fraction will ever be exactly equal to 0, right? Because you only get a fraction equal to 0 if the numerator is 0. But this little expression is undefined at 2. So we have to put a little open circle around it because can't divide by 0. So suppose you put the 10 in for x, 10 for x. Isn't this expression positive? How about if you put in a number less than 2, such as 0? This fraction is negative. All right, which of these two am I going to use for my question? It says less than.
Negative.
So x is less than 2. And just double check up here and see if it makes a true statement. Remember, you really always check back in the original problem. A number less than 2 might be 0. So check x equal to 0. You get 4 over negative 2. Is that less than or equal to 1? Is negative 2 less than equal to 1?
Yeah.
Yep, so I know I'm right. Okay, is that good? So that's number 43, 3.5. Number 43, two people asked that one. Two people asked for that one. Everybody else good on that? And I think that is it for 3.5.
Can you do one like 27? Can you do one similar to 27?
Okay, the question is about number 27 again. Let me get you started on it. We're still on 3.5. It's x cubed greater than x squared. What's the rule when you start to solve for an inequality?
Equal to 0.
What has to be on one side?
Go up to
Zero.
0.
0. X cubed minus x squared greater than 0. So once you get a 0 on one side, what's the next rule?
Factor out
The
Factor.
factoring. Can you go from there? Okay. All right. Let's write in red. 0 on one side. 0 on one side. And then second thing, the big F word, factor completely. Okay? Is that good? Get you going? All right, let's go to 3.6 and see what's going on here. 3.6. First question, 3.6, comes from number 11. Ooh, didn't get very far in this exercise.
plus minus square root.
Okay, 3.6, number 11. It is talking about using the factor theorem to determine if x minus c is a factor. If x minus 3 is a factor, let's go back to the factor theorem. What does the factor theorem tell you?
If you do synthetic division, the remainder is 0, then it's a
The
factor.
remainder is 0. The value of the function at, let's look at the top of page 369. Page 369.
That's when you do synthetic division.
Synthetic division is a good and easy thing to do. It says if the value of the function at c is 0, then x minus c is a factor. So you can actually evaluate at c, but the good old remainder theorem helps you quickly find f of c. Back on the remainder theorem on page 368. The remainder theorem says that if you divide by x minus c, then your remainder is f of c. So the factor theorem and the remainder theorem work really nicely together to help you hurry up and get to your answer. All right, but the factor theorem says if the value of the function at c is 0, then x minus c is a factor. Okay, so let's get back to the problem. Number 11. On page 379. The question is x minus 3 a factor of f of x equals 4x cubed minus 3x squared minus 8x plus 4? So the factor theorem says if it is a factor, that means f of 3 equals 0. So the question is f of 3 is 0? So since this didn't mention the remainder theorem, if you wanted to go put a 3 in and cube it, multiply it times 4, and a 3 and square it, multiply it times negative 3, etc., and add it up, you would be okay. But if you use your remainder theorem, the arithmetic is a lot easier. What would I divide by?
-3.
No, you divide by your c. You divide by positive 3. You get 4 minus 3 minus 8, 4. Bring the 4 down. 4 times 3 is 12. Add. 9 times 3 is 27. Add. I think we did this problem in class. I'm remembering these
Yeah, we
numbers.
did it yesterday.
Oh, yesterday? Okay. Didn't stick then if you ask me again. 19 times 3, 3 times 9 is 27. Was that 57?
57.
And when you
61.
add, you get 61.
Yep.
So this means this is the value of 3. So therefore, by the factor theorem, x minus 3 is not a factor.
Wouldn't it be easier if you just plugged it in?
Well, if you like to, I mean, it didn't mention the remainder theorem, so you could have come in here and put your 3 in.
That'd be easy though.
I thought you had.
Yeah, but in the web assignment, it asks for the factored form,
Oh yeah.
so you have to do synthetic division.
If it asks you to write out all the factors, it says if it is a factor, write f in factored form. But since it's not a factor in this problem, you were done.
Because on WebAssign you had to pretty much do synthetic division to get the
The
answer.
depressed equation.
The depressed.
For this particular question,
You're depressed.
because the instructions in the book says if it is a factor,
Yeah.
then write in factor form, but this isn't a factor, so
So
there
you
would,
just press 0 and put it in.
so you had to find the first zero and put it in?
No, you just put 0 in.
Oh, just put 0 in for the answer, meaning that it was not a factor. Okay? All right, is that good to go for this? And we'll pick up, yeah.
I just have one question. It said, I guess basically it's supposed to be trying to find if it's x minus 3 is the factor.
Right.
So when you do the synthetic division, just change the sign to positive 3.
Yeah, synthetic division, you have to divide by x minus the c. You're dividing by the c. It has to be
Okay.
in the form.
Okay.
So if that had been an x plus 3,
Then it would have been.
then it would have been a minus 3.
Okay.
Anybody else? All right, we'll pick up 13B with the rest of the questions. Everybody? Twenty-one and oh. Oh, so it is different. I will do it. All right, everybody. We are back and working on reviewing for the test, and we're going to pick up at we're in section 3.6 with lots of questions. And the next question was from page 379, number 21. And it was f of x equals 3x to the fourth minus 3x cubed plus x squared minus x plus 1. And the question is, this is a fourth degree polynomial function. What is the maximum number of real zeros that this polynomial could possibly have? I see everybody going 4. All right, could you have 3? Could you have 2? Could you have 1? Could you have 0?
No.
Oh, yes.
Yes.
Yes,
You could have 0 because
Oh,
it's
it's
even. The whole thing could be up above the x or below the x. Maximum number is 4. It then says just make a list of the potential rational zeros, but do not attempt to find. Okay, that's where you have that little p over q bit, right? The p is what factors? Factors of what?
1.
1. That's where you get your p's. So that would just simply be plus or minus 1. Where do you find the factors of your q?
The leading
1 and
coefficient.
The leading coefficient, which is 3. So all the integers you'd multiply together for 3 are
1 and 3.
plus or minus 1, plus or minus 3. So if we combine all this, we'll have plus or minus 1, plus or minus 1/3. So you've got, if this fourth degree polynomial has rational zeros, it will either be a 1, -1, a third, or negative a third, or maybe some multiplicity. Yes?
And if you did try to attempt to find the zeros, would you just plug it in? Plug every rational?
Yep. His question was, I would go with the synthetic division just because I think it's easier, but I would start with the 1. Actually, you can do 1 very easily. Remember I told you the trick of the trade, if you let x be 1, you just add up. 3 minus 3 is 0. Plus 1 minus 1 is 0 with a plus 1, so you know right away 1's not going to work.
So you just keep on going?
Keep on going and try to find a remainder of 0 right here. And then you know x minus your divisor is a factor, or you found one of your zeros. Okay, since this says don't attempt it, it must be that these are yucky problems. Okay, so we'll just do what it says. Is that good for number 21? Okay, let's go to number 39. Okay, number 39 is saying find your zeros. We should have looked at it first. F of x equals x cubed plus 2x squared minus 5x minus 6. Okay, what's the maximum number of zeros, real zeros I could have here?
3.
3. I might have 3,
Two.
2, 1. What about 0?
No.
No, I got to have at least one real 0 because it's got to cross the x-axis. It's an odd power. All right, let's see what we're going to try. Let's get our p over our q's because this problem says find your zeros. All right, the p comes from the negative 6. Do it like this. Plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 6. The q comes from the leading coefficient, which is just plus or minus 1. So if I have a rational zero, it's going to be 1 over 1, 2 over 1, 3 over 1, 6 over 1, or it's just going to be plus or minus 1, 2, 3, and 6. All right. Let's check out 1 real fast and see if that's going to work. If you put a 1 in for x, you're going to get 1 plus 2 is 3. 3 minus 5 is negative 2. Negative 2 minus 6 is not equal to 0, so we already know that 1 is not going to work. All right, so now we get to try some others. Anybody got a suggestion what we might try?
3.
Three.
Going to try 3? Okay, so we have 1x cubed, 2x squared, minus 5x, minus 6. 1 times 3 is 3, add. 5 times 3 is 15, add. 10 times 3 is 30. When you add, you're going to get a positive number. The reason I'm noting that this is a positive number is if I try another number and get negative, my intermediate value theorem is going to tell me I've got something in between. All right, want to try something else?
Why'd you pick 3?
Because somebody up here told me to try 3. No rhyme or reason, I just tried it.
Try negative 3.
Want to try negative 3? That'll probably work. 1, 2, negative 5, negative 6. 1 times negative 3 is negative 3. Negative 1 times negative 3 is positive 3. Negative 2 times negative 3 is positive 6. We got a 0, and we're all excited. All right. What is this? So let's write the factors that we have so far. If negative 3 is a 0, what's a factor? If negative 3 is a 0, what is a factor? X plus 3. And what's the rest of the factor here? What's left over? What's this thing called? Starts with a D.
Depressed.
The depressed
equation.
Right, the depressed equation. So what it's going to be x squared minus x minus 2 from right here. All right, well now we're good because that factors very easily. X plus 3, x minus 2, x plus 1. All right, so our zeros, just to find the zeros, our zeros are negative 3, positive 2, negative 1. Okay?
So then that way you don't have to worry about doing the synthetic division with all the other ones. You just
Okay, that's a very good point. Once you get it factored and you have a quadratic, get off the synthetic division and just go into factoring. Because you might be there half a day trying all the possible ones, but once you got it down to a quadratic, you either factor or go with the quadratic formula to find your other zeros. Good point. Yeah, stop after you get a quadratic.
With
Yep.
the synthetic division again, when can you not use it and you have to use regular long division?
Okay, the question was, when can you not use synthetic division? You can only use synthetic division
It's a whole lot easier than long division.
when the divisor is x minus the r, or x minus the c. So if you're trying to divide by like x squared minus 12 or x squared plus 3, you can't use synthetic division. It has to be x to the first minus r. Okay, another question on that? Is that good? Okay, number 81. 81. Okay, we're on page 380. 81 says, find k such that f of x, which is equal to x cubed minus kx squared plus kx plus 2. Find k so that x minus 2 is a factor. All right, so k is in your third degree polynomial function, and you're supposed to find, well, what is k here, given that this thing is going to be a factor? What do you think you do? I would go with synthetic division, and what's your divisor here? 2. And let's see what happens. 1x cubed minus kx squared plus k plus 2. All right. So 1 times 2 is 2, and that's going to give me 2 minus k. When I add, now 2 times 2 minus k is going to be 4 minus 2k, correct? 2 minus k times 2. Everybody good? And when you add, you're going to get what? 4 minus
1K.
k? Yes. 4 minus k times 2 is going to be 8 minus 2k. And when I add, I get 10 minus 2k, correct?
Mhm.
If x minus 2 is a factor, what do you know about 10 minus 2k? It's got to be equal to 0. How's that going to help me answer the question?
You'll get k.
Now we have to do a solve for k, right? K is going to be, what, in this case, a positive 5. So if you put a 5 in for k up here, put a 5 in for the k, your remainder would have been 0. Problem looked worse than what it was, right?
It was a lot harder the other day.
It looked harder when you did it the other day? Yep. Okay, let's talk about number 83, and I don't think I'm going to do it. We'll just talk about number 83.
Yeah, please.
What is the remainder when this thing to the 20th power is divided by x minus 1? Now, most of you probably wouldn't be overly thrilled with doing division with a 20th power where you got to cover 19, 18, 17, 16, right? But let's see what the remainder theorem, how you can use it. If you're back on page 368, it says, if you divide that function by x minus c, then the remainder is the value of the function at c. So if you didn't want to do long division or synthetic division, either one, you just said it. So you could do synthetic division and find your remainder, but according to the remainder theorem, your remainder is equal to the value of the function at 1, and that would be pretty easy just to plug the 1 in and get it. Does that seem easy now? Too easy? Alrighty, the best I can tell, that was all the questions you guys had from 3.6. Everybody good? My job is to make it look easy, so I hope it looked easy. 3.7. 3.7. First question was number 7. 3.7, page 385, number 7. I don't even think we have to write this one down. The information is given about a polynomial whose coefficients are real numbers. Find the remaining zeros. If you have a third degree polynomial function, third degree, and a 0 is 3, but the other 0 is a, what kind of number is that? Complex number, which is 4 minus I. So if you have one complex number, what's the other 0?
4 plus I.
4 plus I, and those are called conjugates. They always appear in conjugates. So your zeros are 3, 4 minus I, and 4 plus I. Okay? Who asked me that one? Did you? You got it? Number,
That's all I was asking for.
yeah, oh, you just thought that was too easy, didn't you? Don't forget the answers are in the back of the book, so, you know, you can double check and make sure you're good there. All right, number 23. Number 23. You're given the function f of x equals x cubed minus 4x squared plus 4x minus 16, and you're told that 1 0 is 2i, and you got to find all the other zeros. How many zeros are you expecting? 3. If 2i is a 0, what's another 0? Negative 2i. Okay, we did a problem similar to this the other day, and I asked you, give me some suggestions on how you might find the other 0, and y'all all gave me some good suggestions, but my way was easiest. Who remembers my easiest way?
Factor.
You want to write it as x minus 2i times x minus 2i, x minus something.
B plus 2i.
Okay. All right, this was my easier way to do it. All right, so x minus, whoops, sorry.
That's what I was confused with.
Thank you. X minus 2i times x plus 2i. If you multiply that out, what are you going to get?
X squared.
X squared
Plus 4 minus
4i.
minus 4i squared,
what?
right?
Plus
Negative 2i times negative 2i is minus 4i squared. And what's what's I squared equal to?
negative 1.
Negative 1. So this is x squared plus 4 times x minus something or another has to be equal to x cubed minus 4x squared plus 4x minus 16. What?
Hold on. What you just do?
From here to here,
Yeah.
I multiplied this out,
Mm-hmm.
and that gave me x squared minus 4i squared.
Uh-huh.
I squared is equal to negative 1.
Okay.
Negative 1 times negative 4 is positive 4. What's the next step, everybody?
Division.
Division. So you'll divide both sides by x squared plus 4. And just do your long division, which you like doing. Why can't I use synthetic division on this?
So you have
X
x
squared.
cubed.
It's got the x squared. It's got to be x minus the r. Okay, so when you do the long division, I'm going to stop there because we've done a similar problem, and you can do the long division. Whatever this is right there, that's going to be your factor there, and you can read your 0 right off. Yes.
If you had like a perfect square like x squared minus 4, could you still do synthetic if you factored it?
Okay, your question was if you had x squared minus 4.
Yeah.
What you'd have to do is use your synthetic division
Yeah.
with either the negative 2 or the positive 2.
Yeah.
And then part of your depressed equation would have that other factor there. Okay, but because x squared plus 4, you couldn't factor that.
Yeah.
But you could have actually done synthetic division using a 2i or minus 2i. It just gets a little messier. Gets a lot messier. All right, is everybody good on that? 3.7? All right, don't see anything else from 3.7, so we're headed to 4.1. All right, 4.1, and we're on page 403. And the first question comes from 35C. All right, 35C, and this is on page 403. 35C. 35 is f of x equals 3 over x minus 1. G of x is equal to 2 over x. And we're looking for the composition of f and f at x. Okay?
What do they mean by composition?
Composition of f and f at x is f evaluated at f of x. F evaluated f of x. Alrighty. So f of x is 3 over x minus 1. Is everybody in agreement? Who asked me this? I'm looking at your face. You did? Okay. Just wanted to know who to look at because I want to make sure you're happy. All right. Remember, if you're evaluating f at anything, it's 3 over that anything minus 1, right? So if you wanted f at 7, you just put a 7 in for x. But if you want f at 3 over x minus 1, where's that 3 over x minus 1 going to go? Right there. So we have 3 over x minus 1 minus 1. This is f evaluated at that value, 3 over x minus 1. All right, I don't see a happy face. Where can I back up?
No, so far so good.
Okay, so what kind of fraction is this now?
Complex.
Complex or compound fraction? What do you need to do down in the denominator part?
Get that fraction.
Get a common denominator, which is
X minus 1.
x minus 1.
Just the bottom?
Yeah, because the numerator is really already in a single fraction. You could write that as 3 over 1. It's already a single fraction, but the denominator had 2 terms, so you needed to perform the operation given to get it to a single fraction. Okay, so we have 3 over, the little denominator there is x minus 1. So you got 3 minus x plus 1. So you got 4 minus x. And when you divide by a fraction, what do? Everybody knows that. Invert and multiply.
What'd you get 4?
Minus 1 times x and minus 1 times the negative 1 is plus 1. When I'm adding fractions, 3 over x minus 1 minus x minus 1 over x minus 1. Distribute your negative. Common denominator. Did you lose your 4? Is that where you went wrong on the problem? Lost your 4. See, it's not the things that you're learning in this class that is killing you. You need to get a refund on your elementary education where you did fractions. Right back to your school and tell them to give you a refund. You didn't learn how to do fractions.
No, I forgot.
Oh, so it wasn't your teacher's fault? I thought it was always the teacher's fault if somebody couldn't do something. All right, everybody good? Is that good? All right, so 4.1, number 35 was taken care of. We're going to go to problem number 63. 63 we did already on tape. This was my introduction. 4.1, number 63. This was the problem we did to introduce composition of functions. You had to write the surface area in terms of time. So basically you substituted in what your radius was in terms of t. So I'm not going to go back over that one. You can rewind the tapes and get there. Number 65. Let's see what this says. The number n of cars produced at a certain factory in one day after t hours of operation is. So n is number of cars, t is hours. The cost of producing n cars, the cost of producing n cars is this amount. Find the cost as a function of time. Okay, cost is a function of the number of cars. Number of cars is a function of time. Let's make sure we see that. This is number 6, page 403, number 65. Cost is a function of number of cars. Number of cars is a function of time. The problem says find the cost as a function of time. What are you going to do, everybody? How are you going to get this n to be in terms of time?
Solve for 1 t.
Yep, you're just going to take your little n of t and put right here. So you need the cost evaluated at n of t, which just meant you have the composition of c and n at t. So all you're going to do is take your equation for number of cars, put it right there, plug it in your c function, and you got it.
Can't we just write it like that? Or do we have to go and find the number?
You got to find the function.
Okay, so can we just write C, put
But how you say that?
C evaluated to n.
Yeah.
C evaluated to n. So it's going to be C evaluated at n. 100 t minus 5t squared. And then in your C function, that's going to go in, right? So you have 15,000 plus 8,000, and in the place of the n, you're putting 100t minus 5t squared. Does that make sense? Just doing that substitution. Yes? Got to run off the page? Thank you. All right. Is that good? So the trick here, I think, to working these problems is being very careful in that last sentence. Find cost as a function of time, meaning you want C of t. And noticing that now C is in terms of n. N is in terms of t. So you're going to have to take this entire n function and put it right there, and where there's an n, you replace it. Is that good? Which is what we did. Everybody good on that? 69. 69. The volume of a right circular cylinder, that's a can, of height h and radius v has volume pi r squared. Remember, that's the area of the circle times h, the height. If the height is twice the radius, height is twice the radius, express the volume as a function of r. Let's look at that. Take it apart. Number 69. We know that volume is equal to pi r squared h. The next thing it says is height is, in math, remember, is equal to twice the radius. Express volume in terms of the radius. Means that I only want this thing to have r's in it. What are you going to do? Just going to put the 2r in for h. Okay, so it would be pi r squared 2r 2 pi r cubed. The volume now is directly in terms of the radius only instead of the height. Okay? Those look worse than what they are, don't they? The wording, you got to be really careful that you read what it says. Volume as a function of r. V in terms of r. Look at number 70. Volume in terms of r. Number 68. Cost as a function of p. You want C only in terms of p. C only in terms of p. So reading those words sort of helps you do that. Okay? All right, we're on 4.2. 4.2. 417, number 69. Okay, we're section 4.2. 4.2, page 417, number 69. And number 69 says f of x equals x squared minus 4 over 2x squared. X has to be greater than 0. This has a restricted domain to begin with because the function would not have been one-to-one without that restriction. Okay, who asked this question so I know what parts you're asking? Your question was about the domain and range?
Yeah, sure.
Okay. All right, for your inverse function, for the function x squared minus 4 over 2x squared, the domain, they give it to you right here. They're saying restrict for x greater than 0. Now, this is a rational function. A rational function. The degree of the numerator is the same as the degree of the denominator. Do we have a horizontal asymptote here? 1/2. So there's a good chance that x could never be a half. I mean that your y value could never be a half because you got a horizontal asymptote. We don't know if it crosses over it or not. We might write maybe y is not going to be equal to a half. However, because that's your horizontal asymptote. But remember, a curve can cross the horizontal asymptote. We can check real fast by letting y be a half, solve for x. We're going to see if it ever crosses. So we have 1/2 equals x squared minus 4 over 2x squared. X has to be greater than 0, so we can multiply both sides by 2x squared. Okay, so we'll have 2x squared over 2 equals x squared minus 4. If you subtract x squared from both sides, you get no solution. There's no way that 0 equals -4. So therefore, we're saying there's nowhere this curve will cross y equals a half. So our range is all real numbers except y will never be equal to 1/2. Y equal to a half is your horizontal asymptote, and that would be the only place that y might be left out on this. Okay, but with that said, the problem is asking you to find the inverse function. So you remember that the range for the inverse function is the domain of the original. So if we find the inverse function and get its domain, we immediately know the range for the original function. All right, so let me get that. All right, so let's find the inverse. Find inverse. All right, remember you interchange x and y. And now we want to solve for y. So when we solve this, we're going to get 2xy squared equals y squared minus 4. 2xy squared minus y squared equals -4. Remember, if I'm solving for y, I got to get y on a side by itself. Y has to be on a side by itself, so we'll factor out a y squared. 2x minus 1 equals -4. Y squared equals -4 over 2x minus 1. And if we use our square root principle, y is going to be plus or minus square root -4 over 2x minus 1. But we got to do a big alert here. Alert. All right, so the only thing I did was to find the inverse, interchange x and y, solve for y. Now you remember we want the domain for the inverse function and the range for the inverse function. Okay, because the domain for the original function is x greater than 0, what is the range for my inverse function? Y greater than 0. The domain of the original becomes the range. Range would be y values. The range of the inverse. So when I come down here, I have a y is equal to plus or minus this square root. So which one is it going to be based on this information right here? Is it the plus square root or the minus square root? Y equals, y has got to be positive. So you can't use the negative, right?
Yeah.
So it's right here. This is your inverse function because you had that restricted range. And if you look at this, what is your domain for this inverse function?
Same as the range.
Range of your original function, but if you pretend you couldn't find it, you still can't divide by 0, so x can't be a half, right?
Or real.
X can't be 1/2. It's all reals but that. And now that was an easy way to confirm the range of your original function, because the domain of your inverse is your range of your original.
So are you saying when you find the inverse, that's the range?
When you found your inverse function, the domain of your inverse function becomes the range of your original function. The domain of your original is the range. Of course, you got to change your x and y because you interchange those. So the domain of the original goes to the range of the inverse. The range of the original becomes the domain of the inverse. So if you found the domain of the inverse and couldn't figure out the range of the original, you got it by figuring it out. All right, you want to ask another question?
I still don't know how to find the range and the domain just by looking at it like that.
Okay, you know how to find the, well, the domain was given for this.
Yeah.
And if it's the inverse, you automatically have a range.
Like for 67, the domain is all real numbers except for -2, right?
Okay, for 67, the domain is all real numbers except for -2. Perfect.
I don't know how to find the range.
So you,
Well, what is the horizontal asymptote here? Y equal to 2. This is a rational function. So if you're going for a range, the only place it may not be there would be at y equal to +2. Where's your horizontal asymptote
So everything except for 2?
in this problem?
Okay.
I have to be real careful to say always and never kind of deal, because sometimes a graph crosses through its horizontal asymptote. You would need to go and check and see, could y ever be equal to 2?
What about just graphing it and just...
Well, if you graph it, you're going to have to still see, is it going to cross over its horizontal asymptote? But the horizontal asymptote is 2, so if you put a 2 in for y, I can visually see already that the two x's will subtract each other out, and it's not going to cross the horizontal asymptote. So the range is y will never be equal to 2. Does that sort of help?
Yeah.
Okay. All right, that was the only question on 4.2. We're headed to 4.3. 4.3. Got lots of stuff in 4.3. The first one is number... The first one is number 57. 57. This is page 432, number 57. You are solving for x, solve. You have 8 to the x squared minus 2x equals 1/2. What kind of equation do you call this? What's the word? Exponential equation. And in order to solve an exponential equation, you try to do what?
get the same base.
Same base. So if you have 2's and 8's, what's your base going to be?
8.
2. How do you rewrite 8 with a base 2? 2 to what power is a 8? 3.
Oh, yeah.
And how do you write 1/2 with a base 2?
-1.
-1. And how do you handle exponents when you have 2 cubed raised to the x squared minus 2x? Power of a power rule. What do you do to those exponents? Multiply. 3x squared minus 6x. Okay, so now the bases are the same when you have an equation. So what do you do to those exponents?
You solve.
You set them equal to each other. 3x squared minus 6x equals -1, and then you solve. Okay, this is going back to the rule on page 428. 428. If the bases are the same, when you have an equation, a to the u equals a to the v, if you can get those bases to be the same, then you set the exponents equal. And you have a couple examples, 6 and 7, that are nice to follow in the book. Okay? So when you see 8s and 2s, then 2 is a good base. If you see things like 27 and 81, what do you bet would be a good base?
9.
9 would be, how would you write 27 as a 9 to some power?
I guess 3 then.
3 would probably be better. 3 cubed is 27, and 3 to the 4th is 81. Okay, usually go to the prime factors of it to help you. All right, is that good on number 57? Whoever asked? Greg, I think you asked these.
Yeah, that's fine.
Okay, number 72.
No, but you wouldn't solve for 57. You would just say 3x squared minus 6.
No, you have to continue on and solve. I thought if I got you that far, you could solve a quadratic. What's the first step for solving this quadratic, everybody?
Add 1.
Get a 0 on one side, and then you either factor or quadratic formula. Okay? All right, number 72. Same section. 72. 72, 72. Where are you? Oh, 72 was the one we did yesterday in class, right? 72, we'll do it again, just to be sure. You're writing the equation for this exponential. They already tell you it's an exponential function, so you got to write the equation for it. Exponential function. Okay, so you got to know a general formula for an exponential function. And the general formula is y equals what? A to the x. General formula. Exponential function. And this particular problem, you've got some points on the curve. 1 and 5, 0, 1, negative 1, 1/5. Okay, so what are you going to do?
Plug a point in.
Plug and chug. Any of these except 0, 1 is going to be easy. Y is 5 when x is 1. So have we just discovered what a is? A is 5. And so there's the equation for your exponential function, and you can check it using your other point. Is 1/5 equal to 5 to the minus 1? Is 1/5 equal to 5 to the minus 1? And everybody says?
Yes.
Absolutely. All right, is that good? And you do the same thing with number 74. You had a question about 74.
Yeah.
The deal is for 74, you still have y equals a to the x, but your points are like 1 and minus e. So you're just going to substitute in for your x and y, and then you've got your a right away. Okay, check your notes because we did that one yesterday. All right, and we have a question on calculus-related factoring, and that will be it. And then everybody will be making hundreds on the test. Okay, I'm going to go back to page 53, and let's just pull a problem off this because I didn't get a specific question. I'm on page 53 for some of the calculus-related factoring. I'm going to let you guys pick the problem you want to work. Which one?
121.
126.
121? Everybody happy with 121? All right, I'm on page 53. You know this is going to be on your test. Only if somehow I forget it by mistake. It should be on your test and your final exam. We're going to look at number 121 on page 53. 2 times x plus 3, x minus 2 cubed, plus x plus 3 squared times 3 times x minus 2 squared. And the instructions are to factor. All right, let's make sure we know what the word means. What does it mean to factor? It means write it as a product, right? Currently it's written as a sum, two terms added together with a big old plus. We want to write it as things multiplied together. So we're going to use our distributive property in reverse. Here's that little plus coming down. All right, so I'm going to look in the first term and the second term. First I'm going to look at a constant. I have a 2 in the first term, I have a 3 in the second term, so there's nothing common there to bring out. Would you agree? So we'll just put a 2 here and a 3 here. Okay, first term I have a factor of x plus 3 to the first. The second term I have a x plus 3 squared. How many factors are common to both? One of those. So we're going to bring a x plus 3 on the outside. So I'm just going to kind of mark off what I've done. All right, I've already pulled out that one factor of x plus 3 in the first term, but I'm still left with a factor of x plus 3 in the second term. Okay. Now in the first term I have 3 factors of x minus 2. Second term I have 2 factors of x minus 2. How many are we pulling out? 2 of those. That's going to leave me with 1 in the first term, and I've already used them up in the second term. All right, now at this point you need to go back and check. You multiply x plus 3, x minus 2 squared times that first term, you better be back to your original first term in your problem, and then multiply that times the second term, you better be back up here as your little check before you go too far. You're just using your distributive property. All right, so we have x plus 3, x minus 2 squared, and let's clean up inside. 2x minus 4 plus 3x plus 9.
So you only clean up inside, the other ones you just leave?
Well, because you're factoring, these are already written as a product, and sometimes once we get in here, this may factor further once we distribute and combine our terms. So completely factor means that you want to keep breaking it down as far as you can go.
Also, the outside are already factored.
Yeah, they're already factored because you've got factors multiplied together. And here we have 5x. Hey, this is a great problem. Plus 5. Is that completely factored?
Squared.
Oh, squared. Is that completely factored, the 5x plus 5?
Uh-huh. Well, you can take the 5 out.
No, you can take another 5 out. So now we have 5 times x plus 3, x minus 2 squared, x plus 1. So now we are completely factored. Okay, that's one reason you have to for sure clean up, because you may have more factors common.
I got one question about calculus. The problems you gave us on that worksheet.
Uh-huh.
It was number.
You have your worksheet.
No, I don't, but I have the problem.
Here you go.
Give it to him.
Okay. Of this one, which one is it?
It's number 11.
Number 11? Okay. Did you, I'm just looking at it, and I'm trying to guess where you might have had concerns. Does this factor right here, this 2 plus x minus x squared? I bet it factors.
Zoom in on that more.
Can you zoom in on number 11? All right. I think that probably factors to 2 minus x times 1 plus x. I was just trying to see if there was any common factors in there. Is that correct? All right, so what did you pull out of the numerator?
The x. It's the x minus.
It looks like the only thing you pull out is the x
x
minus
minus
1. And it looks like I was thinking that that might have something that would come out, but I don't see that it does. So was that the part that confused you? Because it looked like you still had too much left in there. Yeah, the only thing that's going to come out is, well, remember this x minus 1 here is x plus 1, x minus 1. So actually you're going to be able to pull out an x plus 1 and also a x minus 1. Okay, so be sure you completely factor every little, oh wait, I'm sorry, that's an x minus 1 squared. I thought it was x squared minus 1 squared. So it looks like the only thing you can pull out is a factor of x minus 1.
And then the x minus 1 would cancel out with the one of the x minus 1s from the bottom.
Absolutely.
Okay.
Once you factor out an x minus 1, that would divide out with one of those and leave 3 of those in the denominator.
All right. And there was another one. It was on the first one. Number 3 and 5, because I didn't like on my final answer. I got I had 3x squared. Multiplied by 4x minus 12 and multiplied by 6x minus 12. I wanted to know with those, could you factor those out any further?
Okay, that was the answer you told me. Yes, you would want to factor a 6 out of this, bring it out, and really, I'm surprised the 4x minus 12 is left there. You would want to also bring a 4 out of there. Yeah, so completely factor means that there are no common factors left inside those.
Okay.
Excellent questions, and I appreciate it. Anything else? Yes.
Well, number 4, I got, my final answer was 2 multiplied by x squared plus 4 to the 4th times x minus 2 to the 3rd and times 7x squared minus 10x plus 8. Would I factor the 7x squared minus 10x plus 8?
The question is, when that part was left there, does that, if that factors further, you do. And you can always run to your quadratic formula real fast to see if it does when you don't see right away what to do. My guess is b squared is 100 minus 4 times 7 is 28 times 8. I'm guessing that doesn't factor any further. If you always check out the b squared minus 4ac, if that happens to come out to be negative, you know right away it's not going to factor further in the set of real numbers. Yeah, so don't spend a half a day trying to find it. Right? Is that good? Thank you. Anybody else? Well, I know you're disappointed. Next time, test is next period, and then we pick up with logarithmic functions.
What do you think? What do you think we should
Mr. Cohen?
The question is, what do you think you should focus on for the test? Make sure you can work every example we've done in class, and because I tried to point out the things that are important. Your homework and your textbook are always, and web assignments are to supplement those things so you're good at it. And pay attention to the instructions to the problem so you know how to react to it. You got a question off this sheet?
Off that same answer, 3x squared, 4x minus 12.
Okay, I'll get back with you. Any other general questions, anybody? Okay, make it a great day.